Uh, Thanks, Derek, for the introduction, and also thank you, Mark and Vivi, for that wonderful talk. It was very enlightening, and we learned a lot about how to do, about this challenge and why they thought about this challenge. What are the GPU constraints? What's evaluation of everything? So today I will be presenting. Yeah, thanks for the introduction, Mark and Vivi, once again. And today I will basically be giving some practical tips and will be sharing the starter pack that I've been working for over a week now on how to fine tune LLMs with GPU constraints. And the focus will be uh, 7 billion LLM model. Right. So before I go into the code, let me basically just give the big picture in here. Right. So the big picture is you need to use an open source data. It can be a $16K, it can be OASST1, which is an open system database. You can use any other open source database for that matter to fine tune a language model, right? Then you can again come up with any fine tuning repository or any script for that matter. You can build your own fine tuning repository if you wanna in the course of this competition. And with the data and some fine-tuning code, what we are going to do is pick a base pre-trained LLM. It can be a Llama 2, it can be a Falcon, OpenLlama, it can even be BERT or T5. It's up to you. And I mean, the competition hosts, they have listed down the allowed models that we can pick. So yeah, as they mentioned, we can do the encoder, decoder, or those encoders with decoder style model. So with all of these, what we need to do is fine tune on a single A100 with 40 GB of GPU memory or a 4090 GPU. And once we have the fine tuned model, the competition hosts are going to be evaluating that model against a subset of Helm benchmark. And they also have some holdout secret tasks that they have not shared that they might be using to do like a final phase of evaluation. Right. So this is the big picture. And having said that, there are so many stages and there are so many things to think about the data that you want to curate, how you want to curate, how you want to sample, with the strategies for fine tuning the model. But you also need to be really careful about how you're going to evaluate the model. It's not like a typical Kaggle competition wherein the evaluation data is fixed and also our evaluation metric is fixed. Here, the evaluation is something that you need to think about. Right. I will just give like some 2 cents on the data pipeline and the fine-tuning pipeline. So on the data side, whatever pipeline you have, make sure that it's kind of easy to play with, it's hackable so that you can download whatever data you want to download. Also, it has convenient scripts to convert the data into usable formats. You can mix different open source data sets and also samples from them depending on, the evaluation metric that you want to improve. So all of these should be considered while you're thinking about data pipeline. Also, the data loader should be available both for the training and the evaluation, right? And on the script side of the repository side for fine-tuning, it should have some convenient functionalities to load any model, to checkpoint, to train a model, in this case, fine-tune the model on the data set that you have curated. But given it's a research project, the scripts, whatever pipeline you use, whatever repository you use, make sure that it's easy to hack on, it's easy to add new features, it's easy to try out new functionalities, right? And to be honest, there's like a whole host of options out there. It's just up to you to pick, Google our stuff, see what works best for your hack with it. Having said that, I spent like a few weeks now to curate this repository. So if you go to this link, quantdb.me/neurips-llm-finetuner or scan this QR code, you will head to this repository, which is Neurips LLM Efficiency Challenge. And I just want to give a quick rundown of what you can expect in this repository. So the rundown is basically that this repository is built on top of LibGPT. So the official starter kit that was provided by the organizers, that was also built on top of that LibGPT. But the focus for that repository was mostly to showcase submission, because submission is tricky. I will try to cover that if we have time. So it's built on LeetGPT, but I'm using a fork of LeetGPT so that I can add in some functionalities. I can hack with the original code base and add in some stuff. In this case, I've instrumented the LeetGPT, the fork with return biases, experiment tracking, and I'm working on more functionalities like checkpointing. So if you have a LoRa fine-tuned model, you just provide in the URL from the return biases run, and can then pull the model and do all the evaluation stuff for you automatically. So I'm just trying to build those things. Having said that, I've also documented all the steps that's required to set up your system. And to be honest, it took some time for me, especially because it was me doing it for the first time. And I assume that a lot of folks who will be participating in this competition, they will be doing it for the first time as well. So instead of spending a lot of time, you can maybe just go through the steps that I have documented in the README. Right, and with this repository, especially with LeetGPT, you have strategies like LoRa fine-tuning, QLoRa, like adapter v2, and some convenient scripts for downloading the model, preparing the data, etc., out of the shelf. Yeah, so if you can see the repository in here, as I mentioned, every step has been documented, and it's like you need to create some environment, you need to install some packages. I have also covered some of the gotchas that you might encounter if you are installing Flash Attention. I'm sure you have to deal with CUDA. So in case if you need to update the CUDA version to 11.4 above, there are steps that I have documented that you can just use and it will work. And these are the steps to basically download Flash Attention. So why Flash Attention? It will basically help fine-tuning bigger models because it helps with the memory usage of the model when it's loaded for training. There are some useful tips on what parameters should be used for max job and those stuffs, which you can find in here. And it will just simplify your life and get started. Also, because this whole repository is built on top of LeetGPT, we have convenient scripts to download that model with. So in this case, I'm downloading the Llama 2 7 billion param model, and LeetGPT requires it to be converted to a standard format so that the training loop can consume the standard model format and just use it. And it also have some convenient feature scripts to download the data set and prepare it. In this case, I'm using a Dolly 15K, but feel free to use Red Pajama data 1 trillion, or use your own data, write some script, and you can start playing with that and with the pipeline. Great. So we have some steps to set up the whole thing. Maybe have to take care of CUDA, install Flash Attention, download the data, download the model, etc. A quick thought on the model. If you want to fine-tune a Llama 2, you need to get permission from the authors of Llama 2. And if you go to the model card, the Hugging Face model card for Llama 2, it just need to provide your email ID and click a button, and just wait for a few days, 1 or 2 days, most probably, and you will have access to it. So it's very easy. Great. Now with one line of code, we can start fine-tuning the model. Just to walk through, it's a LoRa fine-tuning strategy that I'm using. I have provided the data directory. I have provided the checkpoint, in this case, a Llama 2 7 billion model. And it's used, I've specified the precision for fine-tuning to be BrainFloor 16. There are other precisions that you can try out, maybe BrainFloor 16 mixed. And depending on the precision, you might get different accuracy, different improvement to the metric, or the metric might even go down, the evaluation metric might go down. So you need to experiment. Also, depending on the precision, the memory requirement will be changing. So a true BrainFloor 16 will consume less memory compared to a BrainFloor 16 mix, just as an example. And recently they added QLoRa, which is a quantized LoRa fine-tuning strategy. which is also great. And they are continuously, the LGBT team is continuously working on making things simpler for you. And in turn, my repository in this case is gonna be consuming those features as well. And I will be adding some functionalities on my own, especially on the MLOps side of things. Great. So just focusing on the fine tuning, what I did was I fine-tuned two models, one a Falcon 7 billion model and a Llama 2 7 billion model. So as you can see, since I was logging everything to virtual biases, you can look through the throughputs, the flops, other metrics that's been generated in that strip and been logged to 1 dB. The most exciting thing while fine-tuning is the loss curve. As you can see, the Llama 2 has a better loss compared to a Falcon 7B model. And just to give important information here, which is both the models were trained on the same data with the same configuration for the same number of steps. So Llama 2 seems to be performing good on the training data set at least. Great. Now let's try to look at one run. So let's look at the fine-tuning of Llama 2. So as I showed, we have the metrics and log, the loss and everything. But what else has been captured automatically for you? So in this challenge, one of the goals is that you only need, or one of the constraints is that you only can train a model for one day, right? So use one GPU and train it for 1 day. So it's important to track the amount of time that was spent on training the model. And in this case, I just spent like 3 hours and 43 minutes. I could have trained longer because I have that budget to go till 24 hours. Great. I can also look at the command that was used to train the model, which is also a good thing because you might be trying out so many things and you need to keep track of what command created that particular metric. Talking about keeping track of things that will directly correlate with the metrics that you are getting, you need to keep track of the configuration. So in this case, I was using a batch size of 128, but the micro batch size, because I was using grad accumulation, was just 1, and it was trained for 20K iterations with a LoRa rank of 4. And if you can see here, I turned the LoRa key, the LoRa query, and LoRa value. So the key, query, and value, these 3 parameters, or these 3 weight matrices in a transformer block were being fine-tuned. And because of that, the number of trainable parameters were only 3 billion in this case. So the original model size is 7 billion or close to 7 billion, but the number of trainable parameters for this fine-tuning job is only 3 billion, which is great. But still, it's a huge model, and you have to come up with techniques and strategies to fit this in a model and train it efficiently. Great. We have configurations, we have the time, track, everything. Great. Now look at the system metrics, because you have just one GPU for 1 day and you need to put in as much data as possible so that the model can see as much data. The more data the model can see in a single day, the better it is. So since system metrics is tracked automatically with 1 dB, we're going to look at the memory allocated. So like 93-ish% of the memory was allocated for this job, while the utilization is not so great. So maybe there's a bug in that bug in my pipeline. That just might be a bug in the LoRa.py script. I'm not sure. It might be something in the way I trained the model, but you can see that with time the utilization dropped. And ideally, we want the utilization to be close to 100% or like about 90%, ideally, because if it's cranking in numbers or utilizing the GPU better, you might be able to push in, shove in more data, in turn improve the metric of the model. Great, so that's metric. Yeah, I mean, you can also look at the exact step that was used in this case. You can also track in the code file. Great. So that's one run that I just ran this one single line of code, which is LoRa.py, and all of this information were tracked automatically because I instrumented the code with 1db. If you are using a different fine-tuning script or different repository, you might find 1db out of the box. If not, you can just instrument it yourself. It's very easy. Great. So that's on fine tuning. Now let's go and think about evaluation a bit. So it's like just 2 cents sharing here, and this is something that's inspired by an idea that was shared by Sebastian Raksha in a PyTorch Lightning blog post that he wrote about this competition. So he said that since the final evaluation will be done on a subset of health, how about we pick some other benchmark, open benchmark like Eleuther's LM eval hardware or maybe Google's Big Bench. And the point is that with, for example, LM eval harness, there's a overlap with the health benchmark. So you can maybe take a subset of LM eval, consider that as a validation set, evaluate your model contact, and use the health like a subset of Helm as a test set and see if the validation is improving and your test is improving as well. If the both are improving, then your model might be generalizing better. So you can come up with good strategies about evaluation. So it's up to you to experiment with different subsets of these benchmarks because, for example, LM eval harness has 200 tasks. So you can pick a smaller subset or subsets that might actually have a better chance in getting a better score on the leaderboard. So how to go about setting up evaluation? Now, I have also documented all of these things here that you can go through. So setting up evaluation with Eleuther LM eval harness, which is straightforward, just clone the repository and install it. I'm also documented. I mean, this is something that I have basically picked from the sample submission starter kit that was provided by the organizers, but I took the liberty of trying it out myself and like documenting what was required in like with some more comments that I felt what might be helpful for all of you. And similarly, I tried using the Helm benchmark, installing the whole thing, and it was also well documented in the starter kit. But again, I took the liberty of trying it myself and like, documenting everything for all of you. And yeah, I also encountered some issues, and yeah, I provided some links that you can maybe try and fix that issues. So that's like you setting up the pipeline and evaluating. Because I was able to do so, we'll just quickly share some interesting evaluation that I was able to do. So I will start with the evaluation on Falcon 7B. So it's the base Falcon 7B, and you can see the numbers here. Just to give some insight, I used 4 tasks: the wiki test, the arithmetic IDC, the truthful QA MC, and the open book QA. So these were the 4 tasks or a subset of tasks from the LM eval harness benchmark. So how is Llama 2 compare on this exact benchmark? Let's see. So as you can see, the perplexity of Llama 2 base model is better than Falcon B. So the lesser the perplexity, the better the model is. So it's better. You can see that Llama 2 is also better on arithmetic tasks. It's slightly better on the truthful QA and open book QA as well. So on open book is kind of hard to say which model is better. So yeah, they're kind of same. Okay, so that's the base model that we compare. So with just this, we can say that maybe picking Llama 2 as the initial checkpoint would make a lot of sense. But again, it's subject to a lot of experimentation, it's subject to your evaluation strategy, and also will depend on the final evaluation that the fine-tuned model will be done on. So that's the base model. But what is more exciting is after fine-tuning the 2 models with the same configuration, same hyperparameters, what's the result? So let me close the base model here, and we can totally see that after fine-tuning, the Llama 2 is performing again better compared to a Falcon B. And if you just look them, like compare them from the baseline, we can totally see that after fine-tuning, after fine-tuning, the perplexity actually got bad for Falcon. Also, if you look at the arithmetic for both Falcon and both Llama, on the arithmetic benchmark, we got zero accuracy. And this might be because Dolly 15K is not actually catered towards like arithmetic-based question answering, which brings to the point that you really need to bring in other data, like data sets, and like mix and match and sample data sets and curate your data set for like improving the overall accuracy, overall metrics, not just accuracy. And yeah, like you can log everything to randomly and look at the dashboard like this and compare results, which is a great way of uh, finding insights from the research that you're doing, finding if whatever research and whatever strategies that you're doing is working out or not. So that was evaluation. I will take a pause right now because uh, this is what I had to cover. Again, I will really love you all to check out this repository that's linked in here. And yeah, try it out. If there's any step that might be misdocumented or it's not working for you, feel free to open an issue. There's a PR if you want. And yeah, I would love to take it from there.